Here, this is the image intensifier tube that's encased in plastic just for protection or whatever this is. I don't know what it's on the inside. And so very lightweight. There's no place to put a cassette of any kind. It's all digital exposure. So if I want to take an image of that, I want you to watch that. Watch the monitor. I'm going to step on the left side of this dead man switch for the camera. And so let's say I'm the radiologist. I see something. I want to take a picture of that to store in memory. Okay, do you see? It took an X-ray. So I was in fluoro mode, and then it went into X-ray mode and took that picture.
So this is spot film?
That's the spot film.
Okay.
Okay? So that will be stored in packs. This happens to be a flat input. I think this is flat, so there's not any vignetting going on in here. So you won't see that fall off in brightness so much in here. Okay, can I have somebody go outside and tell me, I'm gonna fluoro and tell me what the MA reading is, Mr. Nguyen, please? Thank you.
3?
3?
Yeah.
Okay, so it's 3 MA. What's the normal range? 3 to 5. 3 to 5 MA is normal. So thank you. 3 to 5 MA is normal.
So that's one question on review. Say like, what is the tube current on that? And you say 3 to 5.
3 to 5 MA.
Okay.
Yes. Okay. Making sure we've got everything. Okay, now for the fun part. Okay, so I took the lead drape off. This Phillips has some unique things to it. One of them is this. This is, I think, 0.5 millimeter of lead, and this can be removed. This is the lead drape. Obviously, it can be removed. We don't necessarily like to do that. But, so let me give you some history. I remember the lead drape here was solid like this, and it would hang down here. So it was very awkward for radiologists if they were doing anything for the patient, a biopsy or whatever, they're having to do something like that. Then they slatted it, so then you can just reach through and still be protected with it. Dr. Frenosa,
Mm-hmm.
I think I can do this. I don't know if I can do this. You should be the pro at this.
No.
Oh, I got it. I took it off. You think I could do it?
Oh, there you go. Yeah. Oh. Actually,
I just can't see it to where.
don't step on the pedal.
Okay, there we got it. Okay, right there. Okay. And that one goes to the side this way.
This?
Oh, I don't know. Oh, yeah.
There.
We don't have to have that on there, this. Not a big deal. I know, right? Okay, let's just forget it for
Okay.
now. We won't worry about it.
It's a shield.
There you go. Okay, so let's have some fun. This is a Geiger counter, and so I'm going to turn this on. It has a meter, so it can tell you, how much radiation intensity in air is measured in milli-R per hour. Milli-R per hour. So if it reads 200, that's 2.002 R, and if you let this on for a whole hour. Okay, so anyway, this is a Geiger counter. It has a meter reader. and then it has noise. So when you detect radiation, it clicks. Are you okay? Oh, radioactive brains? Oh. Okay, why is it clicking? I don't have any radiation going on. I'm not stepping on anything. Okay, what's going on? Why is it clicking?
Scatter.
Well, I don't have any x-rays on.
Natural radiation.
Natural radiation in the air, it's all around us, and you're gonna get some clicks, so just to freak you out. Isn't that fun? I love that, that's my favorite part. Okay, so let's turn on the machine, and the more clicks, the more radiation exposure, and we can actually measure it. It's pegged over. Okay, so let's put it right here.
Oh, that's nice.
Let's put it right here. Put it right here. Now put it under your lead apron. Just, oh, it's already on. There you go. Now you're standing behind me.
Wow.
Where do you want to stand?
Behind the doctor.
Behind the radiologist who has a lead apron on, okay? So, do you want to stand down here? Let's say they're doing a BE or
Yeah.
an EBE. You're standing down here. Well, let's see, hold it. Come closer. See? Go stand by the door. Okay, so, gives you an idea. Do you want to stand up here? This is, I would stand here sometimes, the patient would be turning and their pillow would get all messed up or they need to drink, and so I'd stand here. You want to step on that for me? Thank you. Okay, so you don't want to be down here either. That's why we've got this lead and this lead. Remember me telling you back in the old days, we would have, when we went to take an x-ray like I showed you, it wasn't on the monitor, it was on a piece of film. And the cassette, the film screen cassette, would be back here. And so I would stand up here, right? Because I called it the back end loader. I would have a cassette clean behind my back, like a CR cassette. And then the doctor, I'd put one in there, and I'd have another one. The doctor would take an image, so the cassette would slide from back here into place, here, underneath, here. And then they would take the x-ray and it would come back here. I'd take it out, put in a new one, put that one on the table over there, away. And so this is where I stood. So go ahead and turn that on. Let me see how bad it is. I don't glow in the dark, so. I have no protection back here. There's no Becky slot cover back here. There's no lead draping or anything like that. So where you want to stand is on that side of the table. Now there will be times when you need to come up here if there's a baby or whatever. I don't want you to be afraid, okay? Your readings are, I've got that times 100. The readings, again, are very, digital fluoroscopy is very low dose, but that doesn't mean you still take your precautions. You have to do what's best for the patient. The other thing, remember that the beam is not continuous. This one is, but your ones out in your hospital will not be. Okay, they will not be. So they're pulsed. Remember the duty cycle. They're only working 10% of the time. Is a very common duty cycle. And so it's pulsing, so that reduces the radiation exposure a lot. So you've got a lot of things in place, but you can't hang out here or down there, okay?
Like me.
Every room has if you don't have it, what if the doctor's out in the remote room? Remember, they're behind this window right here is big. And in 5 times the depth. It's over there. Your rooms out in the hospital will be so much bigger than this. You'll be going, oh my gosh. Okay, so they're way out over there. So what if you have to be close to the patient to give them whatever it is for helping out the doctor? They have portable lead shielding. You don't have the doctor to stand behind, but you have a portable lead shield. It rolls, and you can put it right here, stand behind it, and it has a window. Sometimes they're all clear plexiglass like the windows, or sometimes they're metal, but they have a window that you can see through, and you can stand behind that. So if you're using everything at your disposal, you're well protected. Okay, so just pay attention. If you have to come down here, minimize your time. As I said, when the machine is going on, is activated. When you're leaving, if you're doing the remote room, right, you're the only one in here, stand behind the lead shield, or do what you need to do, and then you step back, and then you turn, because you see how the lead aprons are open in the back. So as you're backing away, you take a couple steps. We don't want you to fall. We don't want you to trip. But you exit the room like this, and then you can turn out and go. Okay? You just don't want to be here and then decide you're going to leave, right? So again, is it going to give you a high dose? No, but it's those little things that protect you. Like I said, they do make these where they wrap around whole. I mean, there's no opening, but it's a lot heavier. You're feeling the weight a little bit. So you can imagine, this is the first thing we want to do when the exam is over with. And you're to hang these and not, now, the old ones are made of real lead. So if you fold over a period of time, it eventually cracks. And how do you know? How are you going to test for lead aprons to see if they're cracked or not? Because we've got this vinyl protective, we X-ray, we fluoro. Just drag it through and see. It should be clear. And if you see a black streak, that means there's a crack. Air's going through. Okay, or radiation's going through. And so you don't want to wear, if it's cracked anywhere, we don't use it. The new ones are not made of lead anymore. They're made of what they call lead equivalent. I don't know what materials those are, but I think they're a little bit lighter, and I don't think they have that breaking problem, cracking problem like we used to. So that's why they say lead equivalent now. But we still call them lead aprons. We don't go get the lead equivalent apron. They'll go, oh my God, you're a newbie. so now, are there any questions? I'm trying to think. There are some acquisition rates here, on here. On here, I don't know. Oh, what? Here they are. Oh, speed. They call it speed. So it can go 8 images per second or 6, 4. So the speed goes down to 1 image per second or half an image per second. So if you're doing an esophagram or something like that, you might want to take, I'm sorry, here you can see. Right there, there's 8. It's kind of hard to see. If you're doing an esophagram, you might want more images per second just because it goes fast. If you're doing a BE and the barium's kind of going slower, you can do a slower speed. Okay, the more images per second and the more radiation exposure. So I don't know. It's kind of fun. We tend to watch what the radiologist is doing with the patient, but when you get the opportunity to get out there, watch what they're doing up here sometimes. You don't always have to watch the patient. See what the radiologist does. Because your job is to help them and support them. So anytime they're having trouble with something, who knows this equipment? You are supposed to know the equipment. So that's one thing we have you do as a new student. If you've got some downtime, come in here, you can turn it on, you can set it up, you can practice these things. You cannot energize a real patient without direct supervision.